Number 9, we're going to solve the equation. So I'm going to start out, I'm going to subtract 25 from both sides. And then I'm going to come over here because I didn't leave myself enough room. 36x squared is equal to 25. Divide both sides by 36. Now, the fraction here I have does not reduce, but hopefully you guys notice when you're looking at these are both perfect squares. Forgive, I should have put a negative in front of that 25. Now, the square root of 25 is 5, and the square root of 36 is 6, and because that 25 ended up being negative, I need an I in my answer. So, actually two answers there, plus or minus 5/6 I, that's got an imaginary solution. Now, for number 10, I don't have any information given to me, and I do have a glare on the screen, so let's move this over here, see if we can get rid of that. First thing I want to do if I have a polynomial function I don't have any information about, I'm going to type that polynomial into my y equals, and I'm going to see if I can use the graph to get myself a 0. Now, if I don't know, what I might do just real quick before I graph this, I'm going to hit the zoom button. If you hit number 6, that'll take zoom standard, that'll take and give you a negative 10 to 10 for X and Y window, just kind of like the default with what the graphing calculator comes with. Usually on that screen you can see what you need to see. So for right there, that looks to me like it goes through -3. So let me just confirm that. I'm going to hit second graph so I can look at the table, and I thought that was going through -3, so let me just zoom up here. Yep, -3, the y value is 0. So I should have 3 answers to this question because it's x to the third. One of them I can see from the graph is -3. Now, if you have a 0, that's going to correspond to the linear factor x plus 3. What I need to do here, though, is break down the polynomial using this. And you can use long division or synthetic. I'm going to go ahead and use synthetic here because it's going to take up a little bit less space. Now, I should know I should not have a remainder here as I go through. So use your 0 on the outside. -3 times 1 is -3. We're going to bring that down, multiply, add, multiply, add. This will be -4. -3 times -4 is going to be positive 12. 17 and 12 is going to add up to 29. And -3 times 29 is going to give me -87. I should not have a remainder here. This place would be the remainder, plain number, x squared. So, let me just write this real quick. We know x plus 3 is a factor. Our leftover x squared minus 4x plus 29. Now, what I would do there is try to see if I can factor that, and I can't think of any numbers that are going to add up to give me 29, or multiply to get 29 and add up to get -4. So what we're going to need to do here then is the quadratic formula to get our other two answers. So two things multiplied together to give me 0. If this is 0, it'll make the equation true. We'd get that from the -3. To get the zeros of this, like I said, we're going to have to do the quadratic formula. See if I can fit it on here. Opposite of b would actually be positive 4, plus or minus, I'm just going to grab the calculator here. Let's see, b squared. This would be -4. Make sure you put that in parentheses, squared, minus 4 times our a value would be 1, and our c value is 29. So I have -100 under my square root, and 2a would just be 2 times 1. Now, this is super nice for us because 100 is a perfect square. Negative perfect square, or -100 is a perfect square in imaginary land, so this is 10i. And then before I write my answer to the question here, if these three numbers are all divisible or can be reduced, you can do that. So each one of these is divisible by 2. So I'm going to write 2 plus or minus 5i. Those are my other two answers. So totally for this question, I have 3 answers. The -3 here, and then 2 plus or minus is 2 different answers. So 2 plus 5i and 2 minus 5i. Number 11, we're going to write an equation here for absolute value graph. Alright, so I want to identify the vertex because that's part of the formula. This looks like we're doing 3, 4. Okay, General form for absolute value, x minus h plus k. hk is the vertex. Now, your a value is like your slope. So in this case, on either side of this, I'm going down 1 over 1, down 1 over 1. So that a value is just going to be a little negative 1. So I'm just going to put a negative symbol here. My vertex is 3, 4. So if this is positive 3, it's x minus h. It's actually going to look like a negative 3 in the actual formula because of the way that's set up. And then plus k, k is 4. Plus 4. That's what I'm looking for my equation. Number 12, we're going to solve this system of inequalities by graphing. So I'll just start with the first one. We're going to start at 4 on the y-axis. My slope is negative 2 or negative 2 over 1, rise over run. So I'm going to go down 1, 2 over 1, down 1, 2 over 1. And let's see. This is just a strictly less than. So this should be a dotted line, and less than, I'm going to shade below. I'm going to wait for a second to do any shading on this question, but this should be a dashed or dotted line. The other inequality here, we've got y is greater than or equal to, so that should be a solid line, and greater than is going to shade above. This is going to start at negative 3. Our slope rise over run is a half, so I'm going to go up 1 over 2, up 1 over 2. And I'm just going to connect the dots here. That should be a solid line. Now, I am supposed to be less than the dotted line. That would be underneath there, and greater than the solid line. So to fit both, grab my highlighter here, my overlap in my shaded region, all these points that would fall in here, all these points would be solutions to this system. Okay, number 3, this is a 3 by 3 system of equations. So if you guys remember back, there's a lot of space on this problem because it's going to be a little bit of a challenge here. You can use substitution or elimination. Let me label these lines. I'm going to call them lines 1, 2, and 3. To me, immediately when I look at that system, if you ever have a variable that just has a 1 in front of it, like I have the x, that's really easy to use in your favor to get an elimination situation going on. So here's what I'm going to do. I'm going to take that first line, I'm going to multiply it by 3, and that's going to allow me to eliminate x if I match that up with the second line. So let me go through here. This would be 3x, 6y, 15z, and that would be equal to 3 if I multiply everything by 3. I'm just going to copy the second line. Negative 3x plus 3y plus 7z is equal to 4. Now my goal there was to get rid of x, so that's why I matched those two up. They were opposites, that adds up to 0. This would be 9y, 22z, and 7. Okay, now I need to repeat that process. I need to pick 2 different lines in the equation, but I do have to tackle the same variable. So since I decided to get rid of x, whatever 2 lines I choose for my second step here, I need to also eliminate x. So what I would say to you, I'm going to take 8 times that first line, and I'm going to match that up with the third line in the equation. So everybody on top gets multiplied by 8, so 8x plus 16y plus 40z is equal to 8. And then I'm just going to go ahead and copy the line at the bottom of the system, the negative 8x, 5y, 12z, and 11. Now again, I had to eliminate the same variable, so that's getting rid of x. This is 22y, 52z, and this is 19. Okay, so we started with 3 equations and 3 variables. Now we have 2 equations and 2 variables. I'm going to kind of come over here and match these up. Oh my goodness, I can't add apparently. 21y, sorry about that. Okay, now if I'm looking at this, to be honest with you, there's not an easy, we're going to multiply this line by a number to match these up. So what I'm going to do, I'm actually going to multiply both lines. I'm going to go for y here just because the coefficients are a little bit smaller. So I'm going to multiply the top line by 21 and the bottom line by -9. That'll create opposites. And I'm going to grab my calculator here because those are some kind of big numbers there. So let's do 21 times 9. So that would give us 189y. 21 times 22 is going to give you 462z. And 21 times 7 is going to give you 147. Okay, now the bottom line, I'm using -9 so that my y's will be opposites, and I can just add the bottom line to the top line here after I construct that. So if you do -9 times 21, you should see it should be -189y, which is what we want, so we can cancel those out. -9 times 52, -468 for our z's, and -9 times 19, -171. Y's are gone here. Now, all I've got going on this question, this is just going to be -6z, and 147 plus a -171 can give you -24. And then I know I'm in good shape because I'm going to get a nice number here. So divide by -6, z is just going to be 4. Okay, now when you solve these questions, you got to get 3 values, one for x, one for y, one for z. So totally up to you. You can plug this back in anywhere you want to in the system you just used. I'm going to use one of the lines from the system before we started manipulating it because the numbers are a little smaller. So I'm going to do 9y plus 22 times 4 equals 7. I'm just plugging it into that line right there for z. So 9y plus 22 times 4, don't need my calculator for that, it should be 88. And then I'm going to get y by itself. So if you do 7 minus 88, 9y is equal to -81. And then if I divide both sides here, y is just going to be -9. Now, to get my final answer to the question, I need to plug this back into one of the equations that has all 3 variables. And let me see if I can slide this down so I can get on the screen. I'm just going to use that very first equation. 1 plus 2 times y. And I know y is -9 now. Plus 5 times z, and I know z is 4. And this is supposed to be equal to 1. Okay, so I'm just plugging it into that very first equation in the system. You could use any of those 3 at the top. This will be -18, 20. So this is going to be x plus 2 is equal to 1. If I subtract the 2 there from both sides, x is going to be -1. Okay, now I don't have any room. Tried to write kind of small. So I'm just going to come up kind of in this space up here by the graph. When you guys see the answer here, it's written as what we call an ordered triple, x comma y comma z. So my x value should be -1, y value should be -9, and z should be 4. So this is how we would have the answer appearing in the multiple choice options. Number 14 just says state the vertex and the axis of symmetry. So, whoops, I'm just going to write the vertex form so you guys can see where I'm grabbing this from. This is x minus h squared plus k. Now, I call this opposite copy. Whatever is inside with the x is the opposite of what it looks like. It's what would set that equal to 0. So -8 is going to be the x coordinate of your vertex. K, you just go ahead and copy that. So -8, -6. This is the vertex. The axis of symmetry always goes through the x coordinate of the vertex. It's a vertical line, so it should just be x equals whatever the x coordinate of your vertex is. In this case, that's going to be -8. Slide this up. We'll try to get 2 more on this video. For number 15, solve the system. This is what we were doing in number 13, but this is just a 2 by 2. I think it would be easy to eliminate with the y here. I'm going to multiply this by -4. Actually, what am I doing? Let me eliminate the x's. I could just multiply one of these lines by -1. and then we can cross our x's out. So let me just copy. I have 2x minus 4y equals negative 12. I'm going to go through and multiply by negative 1 in that second line. These eliminate because they're opposites. Negative 4 plus 1, negative 3. Negative 12 plus 3 is negative 9. Y is going to end up being 3. And I just need to plug that back into either of the equations there. So I'll do 2x minus 4 times 3 equals 12. And I'm going to add 12 to both sides. So x should be 12. Oh, guys, please forgive me. I'm so sorry. I just realized I made a mistake back here. Hold on a second. Sorry. I accidentally wrote negative 12 there. I really apologize. So that should have been positive. This would have been 15. This would have been negative 5. Sorry, I screwed that up. Y is going to be negative 5. So let me try that again. So it should be 2 times x minus 4 times negative 5 equals 12. I'm going to get 2x plus 20 is equal to 12. If I subtract 20 from both sides, 12 minus 20 is negative 8. And then if you divide by the 2, x should be negative 4. So my answer to the question, got to write it as a coordinate point. Negative 4 is your x coordinate. Negative 5 is your y coordinate.